So, what we are going to discuss today is unsupervised learning or clustering. So, earlier whatever classification or the classifier design techniques or the learning techniques that we have talked about, in all the cases we had some training samples, that is the samples for which the class belongingness is known. So, we have taken few samples from various different classes, and using those samples or labeled samples we have tried to design the classifier, or in case of neural network we have tried to train the neural network. And because in all those cases you make use of labeled samples to design your classifier or to train the neural network, such a kind of approach is called supervised learning, because your learning process is supervised by the set of labeled training samples. Whereas in the other kind of problem domain where you have been given a set of raw data, okay, and we have to partition that set into a number of subsets, where we have to consider that the samples belonging to one subset, they are similar based on some similarity measure, whereas if I take samples from different clusters or the samples from different partitions, then those feature vectors will be dissimilar based on the same similarity measure. And this is a kind of approach where you try to partition the set of feature vectors into different partitions, is what is called unsupervised learning. Okay, because here we don't have any set of labeled training data to guide the partitioning process. And there are different types of approaches for this clustering problems. One of them is called agglomerative clustering. So, what we will be doing today is what is known as agglomerative clustering. So, agglomerative clustering is actually a hierarchical process. That is, either we can have a bottom up approach or we can have a top down approach. So, in the bottom up approach we can assume that initially all the samples or all the feature vectors which are given, they form actually singleton sets. That means, initially if I have n number of feature vectors, then initially I will have n number of clusters where every cluster will consist of a single feature vector. Then hierarchically you go on combining the feature vectors into different groups, and that way you generate a tree kind of structure. So, this is what is bottom up approach. And the other one is top down approach, where initially I can think that all the samples belong to the same cluster. That means, I have a single cluster, and then try to divide that clusters into number of clusters in a top down approach. That is also agglomerative clustering, but it is top down agglomerative clustering, or the approach that you are taking is a divisive approach. That is, starting from a single cluster, you try to generate a number of clusters. That is, you are dividing the single cluster into number of clusters in a hierarchical manner. So, whenever we go for, say, initially let us take this bottom up approach, that initially I have n number of feature vectors. So, the total number of feature vectors which are given is capital N, which I can mark as say x1, x2 up to say xn. So, these are n number of feature vectors. Every feature vector will be of dimension say d. So, I have this n number of d dimensional feature vectors. Okay. So, the simplest approach is, as I said, that initially I will assume that I have n number of clusters where every cluster consists of a single sample. Okay. Then hierarchically I will go on combining them. So, it is something like this. So, in the first step I begin with n number of clusters. where every cluster consists of a single vector. Okay. Then in the second step, what I can do is I can have a repetitive approach. So, I can repeat the next step n minus 1 times. So, in step 3, what I have to do is I have to find most similar pair of clusters and merge those two clusters. Okay. So, if I do it n minus 1 number of times, you find that at the bottommost level, I start with n number of feature vectors. So, there are total n number of feature vectors. Then what I do is in the next step, I find out the most similar pair of clusters. Okay. So, suppose these are the two clusters which are most similar. So, I have to merge them. After merging them, the number of clusters that I have is n minus 1. Okay. In the next step, again maybe that this cluster has become similar to some other cluster over here. So, I have to merge these two. Okay. So, in this step, in the third step, I have n minus 2 number of clusters. So, this way, if I go on merging pair of most similar clusters in every step, after this n minus 1 number of steps, I will have a single cluster where all the samples are put in the same cluster. Okay. So, I have a complete tree structure, and you find that this tree that you are going to create is a binary tree, because at every step I am combining only two of the clusters into a single cluster. So, the tree will be a binary tree, and I can break or I can terminate creation of, this is what I said is this is the maximum number of steps that I can perform. I can terminate this algorithm at any step where I have attained the required number of clusters. So, I can specify that what is the number of clusters that I need, and I can terminate this algorithm at any step when I reach the desired number of clusters. Okay. So, these are the basic steps in this agglomerative clustering or bottom up agglomerative clustering. Okay. So, what I have to find out is I have to find out the most similar clusters, the pair of most similar clusters, and it is the measure of similarity that decides that what kind of clustering algorithm or what kind of agglomerative clustering algorithm that we are going to have. Okay. So, as we said that when it comes to the terms of feature vectors, then my pattern is actually represented by a point in the d-dimensional feature space, because our feature vectors we are assuming to be d-dimensional feature vectors. So, every pattern is actually represented by a point in the d-dimensional feature space. So, to measure the similarity between two different patterns, I have to measure what is the distance between the corresponding feature points. Okay. So, if this distance is very high, I can say that the patterns are not similar. If the distance is small, that means the points are very close to each other, we can say that the patterns are similar to each other. Okay. So, basically what we are doing is we are trying to find out some sort of distance value between two feature vectors, say xp and xq, and this distance value is the measure of similarity or the measure of dissimilarity between those two feature vectors. Now, when I say whether two clusters are similar or not, okay, that means I have to find out what is the distance between two clusters, or what is the distance between, and every cluster is nothing but a set of points. So, I have to find out what is the distance between two sets. Okay. So, accordingly, there are different types of distance measures that can be defined between two sets. One of them is called single linkage, and according to the distance function, the distance measure that we use, I can have different types of algorithms. One of them is called single linkage algorithm. or this is also what is nearest neighbor algorithm. Okay. The other algorithm that I can have is what is called complete linkage algorithm. Or this is also called farthest neighbor algorithm. Or we can have something called average linkage algorithm. Okay. So, what is the single linkage algorithm or the nearest neighbor algorithm? Suppose I have got two sets of points, okay, and I find out a point from first set and a point from the second set which are nearest. Okay. So, I form every pair of the feature vectors with one pair from the first set and one pair with one feature vector from the first set and the other feature vector from the second set. So, for every such possible pair of feature vectors, I compute what is the distance. Okay. And the single linkage or the nearest neighbor algorithm says that out of all these distances that I have created, I have to consider which is the minimum distance. Okay. So, formally it can be defined like this: the distance DSL or single linkage distance is nothing but, so single linkage distance between two clusters Ci and Cj, it is nothing but compute the distance between two feature vectors A and B, where say A belongs to cluster Ci and B is taken from cluster Cj, okay, and I have to compute the minimum of these distances. Okay. So, I take one feature vector from Ci, other feature vector from cluster Cj, find out the distance and compute this distance for every pair of such possible feature vectors. Okay. And I have to compute what is the minimum of these distances. So, the single linkage algorithm is based on this minimum distance. Okay. Whereas, the complete linkage algorithm, so if I put it as DCL, between the same Ci and Cj, between the two clusters Ci and Cj, this will actually be maximum okay. So, in case of single linkage, it is the minimum distance. In case of complete linkage, it is the maximum distance. That means, I have to consider the farthest pair of feature vectors with one feature vector from cluster Ci and the other feature vector from cluster Cj. Okay. And in case of average linkage algorithm, I have to find out the average of the distances. So, I have to compute what is the average of these distance values, and that gives you the distance between two clusters Ci and Cj. Okay. So, in this case it is the minimum distance, in case of complete linkage it is the maximum distance, and in case of average linkage it is the average distance of the pair of feature vectors with one feature vector taken from cluster Ci and the other feature vector taken from cluster Cj. So, now let us take an example to illustrate these different algorithms or what clustering result we obtain using these different algorithms. So, let us take a set of feature vectors. Okay. and I put this as, and I assume that I have two dimensional feature vectors. So, the feature components are x and y, okay, and I take a number of points. So, the first feature vector, suppose it is 4 4, the second feature vector is suppose 8 4, third feature vector let me take as 15 8, fourth feature vector maybe say 24 4, and the fifth feature vector I take as say 24 12. Okay. And let us first see that what will be our clustering output if I go for single linkage algorithm. Okay. So, to have the single linkage algorithm or to have the clustering, I have to find out the distance between every pair of clusters, and what we are assuming that initially I assume that each of these feature vectors form a singleton cluster. Okay. So, what I have to do is I have to compute the pairwise distance. I will put it on another page. So, firstly what we will consider is the single linkage algorithm. Okay. So, I have to find out the distance between the pair of feature vectors. Okay. So, I have first feature vector, second, third, fourth and fifth. Total I have 5 feature vectors. Okay. So, naturally distance between 1 and 1 is 0 because it is the same point. I have to find out what is the distance between 1 and 2. Okay. So, here you find that your first point is, the first feature vector is 4 4 and the second feature vector is 8 4. So, if I compute the distance between the first feature vector and second feature vector, obviously it is 4.0. Okay. So, 1 2, the distance is 4.0 and obviously 2 1, that will also be 4.0. Okay, because this distance function is symmetric. Similarly, if I compute the distance between 1 and 3, 1 is 4 4, 3 is 15 8. Okay. I can compute what is the distance between these 2 points 1 and 3, and the distance between 1 and 3 comes out to be 11.7. Okay. So, similarly, the distance between 3 and 1, that will also come out to be 11.7. Then distance between 1 and 4, that will come out to be 20.0. So, 4 and 1, that will also be 20.0. Similarly, the distance between 1 and 5 will come out to be 21.5. Here also 5 and 1, this will be 21.5. I do not really want what is the distance between 1 and 1 because that is equal to 0. Similarly, distance between 2 and 2, I am not, that is also equal to 0. So, what is the distance between 2 and 3? Again I can compute. 2 is, feature vector 2 is 8 4, 3 is 15 8. I can compute what is the distance between these two, and this distance comes out to be 8.1. Similarly, 3 2, it will also be 8.1. Okay. Then what is the distance between 2 and 4? This comes out to be 16.0. So, 4 2, that will also be 16.0. Okay. Then 2 and 5, this comes out to be 17.9. Okay. So, 5 2, that is also 17.9. Here it is 3 3, again it is 0. What is the distance between 3 4? If you compute, this will come out to be 9.8. So, 4 3, this will also be 9.8. Okay. 3 5, this distance also comes out to be 9.8. 5 3, 9.8. Okay. again 4 4 I do not bother, it is equal to 0. Distance between 4 and 5, this is 8.0. So, 5 4, this is also 8.0. What is left out is 5 5, that is 0. Okay. So, I have got a distance matrix, and this distance matrix tells you that what is the distance between every pair of feature vectors. Okay. Now, out of this I have to take that pair which has got minimum distance value. Okay. So, if you look at this distance matrix, you find that the pair 1 2 that has the minimum distance, which is equal to 4. So, at the first step I have to combine the feature vector and 1 and 2 into a single cluster, and other feature vectors will remain as singleton clusters. Okay. So, in the second step, so what pair I have formed over here is 1 2, that gives me one pair, feature vector 3 remains as a singleton cluster, 4 remains as singleton cluster, and 5 also remains as singleton cluster. Okay. So, after first step, this is the clustering output that I have got. Now, I have to do the clustering using this at the second level. So, at the second level, the clusters that I have is 1 2 coming to a single cluster, 3 4 5, here also 1 2 3 4 and 5. Let us put them as set. Okay. So, again distance between 1 2 and 1 2, obviously it is 0. What is the distance between 1 2 and 3? Okay. To compute the distance between 1 2 and 3, I have to compute what is the distance between 1 and 3. I have to compute what is the distance between 2 and 3, and because it is single linkage algorithm, I have to take the minimum of these two distances. Okay. So, from here you can find that the distance between 1 and 3 is 11.7, the distance between 2 and 3 is 8.1. So, minimum of these two is 8.1. Okay. So, I have to take that 8.1 as the distance between this cluster and this cluster. Okay. So, similarly, here also the value will be 8.1, right. Distance between 1 2 and 4, distance between 1 and 4 is 20, distance between 2 and 4 is 16.0. So, the minimum of these two is 16.0. Okay. Similarly, over here the distance will be 16.0. Between 1 2 and 5, distance between 1 and 5 is 21.5, 2 and 5 it is 17.9. So, the minimum is 17.9. Here also it is 17.9. Then the distance between 3 3, obviously it is 0, I do not need it. 3 4, because 3 and 4 still remains as singleton sets. So, it is the same distance value which will repeat. 9.8, here also 9.8, 4 3 9.8, 4 4 is 0, 4 5 it is 8.0, then 5 3 it remains as 17.9. Okay. 5 3 is 5 3 9.8 or 5 4 9.8. Okay. And what is the distance between 5 4? All right. 5 4 it is 8.0, 5 5 it is 0. Okay. Now, again I have to find out that what is the minimum of these distances. Okay. So, here you find that minimum of this distance is 8.0. So, at the next step I have to combine these two feature vectors 4 and 5. So, after second step, the feature vectors that I have or the clusters that I have is 1, 2, that remains as a single cluster, then 3 and then 4, 5. So, these are the 3 clusters that I have made after step 2. Okay. So, this is what I have got in the first step, this is what I have got in the second step. Then again I have to perform the same operation. So, next the feature vector, now the clusters that I have are in step 3, 1, 2 forms one cluster, 3 is the other cluster and 4, 5 that makes the other cluster. Okay. Now, in the same manner, if I compute the distances between each pair of clusters, so obviously 1, 2, 1, 2 has the distance equal to 0. So, I do not bother about this. 1, 2 and 3, it remains same as 8.1. Okay. So, 1, 2 and 3, the distance remains as 8.1. Here also the distance remains as 8.1. When you compute the distance between these two clusters, cluster containing the feature vectors 1, 2 and the cluster containing the feature vector 4, 5. So, what I have to do is, I have to find out distance between 1, 4, distance between 1, 5, distance between 2, 4 and distance between 2, 5. So, I get 4 possible distance values, I have to take minimum of these 4 and here this minimum distance will come out to be 16.0. Okay. Similarly, here also the distance will come out to be 16.0. Then 3, 3 I do not bother. The distance between 3 and 4, 5, you can find out that this is 9.8. So, obviously 4, 5 and 3, this is also 9.8. Okay. And here the distance value is 0. So, now I have to take the minimum of all of them. So, the minimum comes out to be this 8.1. Okay. So, in step 3, my clusters are 1, 2 and 3, these are combined together and the other cluster consists of 4 and 5. Okay. And obviously, the final step that we can have in the fourth step, now I am left with only 2 clusters. So, these 2 clusters are to be combined together. So, I get a single cluster 1, 2, 3, 4, 5. Okay. So, now you see that the initial algorithm that we stated, that if I have n number of feature vectors, I start with n number of clusters and this merging of 2 nearest clusters, this has to be repeated for n number of 1 times or n number of 1 steps. So, here we started with 5 different feature vectors initially taken as 5 different clusters. So, after n minus 1, that is after the fourth step, all of them have been combined into a single cluster. Okay. So, if I put it in the form of a tree, a bottom up tree, so I have this cluster number 1, 2, 3, 4 and 5. Okay. So, initially what we have done is we have combined feature vector 1 and 2 to give me a single cluster. So, that is what we have done in step 1. step 2, we have combined 4 and 5 into a single cluster. So, this is step 2. In step 3, we have combined 1, 2 with 3. So, this is what we have done in step number step number 3, and in step 4, this and this will be combined together to give you a single cluster. So, this is after the 4th step. So, you find that what I get is a tree structure, and as we said that tree structure, this tree structure is a binary tree, because at every step we are combining only 2 of the clusters into a single cluster. Okay. And this complete diagram is called a dendrogram. Okay. So, if I am interested in only 2 clusters, I will stop this agglomeration process at this level after step 3. If I want 3 clusters, I will stop it after step 2. Okay. If I want 4 clusters, I will stop it after step 1. So, depending upon the number of clusters that I need, I can stop this agglomeration process at the appropriate level. Okay. So, this is the kind of clustering that you have got using this nearest neighbor or single linkage algorithm. If I go for the furthest neighbor or complete linkage algorithm, then let us see that what kind of result that we are going to get. So, if I go for complete linkage algorithm, your step 1 will remain the same, because I will have the same sort of distance values for every pair of feature vectors. So, my step 1 will remain the same. After step 1, I have to take the minimum distance, and using this minimum distance I can combine 1 and 2 on B. Okay. So, clustering up to step 1 will remain same as what we get in case of a single linkage algorithm, and then onwards there may be a difference. Okay. So, after the first step, the clusters that I have is 1, 2, 3, 4 and 5. Okay. No. The distance is minimum. When I am computing the distance, I am taking the distance as maximum of the pair of distances. You come to this definition, but your similarity is based on minimum distance. Come to this definition. What is the single linkage distance between Ci and Cj? The single linkage distance between Ci and Cj is the minimum of this pair of distances. I have to take one feature vector from cluster I, the other feature vector from cluster j. I have to find out what is the distance, and this I have to do for every pair of feature vectors, with one taken from cluster I, the other one taken from cluster j. Okay. So, if I have k number of such pairs, I will have k number of such distances. I have to take the minimum of these distances to give me what is the distance between the clusters Ci and Ck. In case of complete linkage, here I have taken the minimum distance, here I will take the maximum of those k number of distances. So, maximum of those k number of distances gives me the distance between Ci and Cj. In case of average distance, it is the average of those k number of distances that will give me the distance between Ci and Ck. So, I am taking minimum, maximum or average to compute what is the distance between the cluster Ci and the cluster Ck. Okay. Now, the similarity between cluster Ci and cluster Cj is based on this distance. Okay. So, I will say that Ci and Cj are most similar if the distance between Ci and Cj is minimum among the distances between every pair of clusters. Is that clear? So, to say whether two clusters are similar or not, the distance between those two clusters have to be minimum. But it is the distance between the clusters when I compute, that computation is one of these. How do you compute the distance between two clusters? The distance between two clusters using the single linkage algorithm is this, using complete linkage algorithm is this, using average linkage algorithm is this. And once I find out the distance between two clusters, the clusters having minimum distance, they will be most similar. Okay. It is not the maximum distance among the clusters, because then the clusters are farthest. So, these algorithms, single linkage, complete linkage or average linkage, this tells how do you compute the distance between the clusters. That is all. And once I get the distance values, then the pair of clusters having the minimum distance in whichever way I compute, that pair of clusters is the most similar pair of clusters, and I have to combine them. Is that okay? Right. So, here what I have is, I have 1, 2, 3, 4 and 5. Okay. Now, the entries in this matrix is likely to be different than what I got in this case. Okay. Here what I have done is, to find out the distance between 1, 2 and 3, I have computed the distance between 1, 3 and I have computed the distance between 2, 3. Out of these two distances, the minimum value I have put. Now, out of these two distances, I have to put the maximum value. Okay. So, come over here, what is the distance between 1, 2? It is 4.0. Distance between distance between 1 and 3, it is 11.7, and the distance between 2 and 3, it is 8.1. Okay. So, I have to take the maximum of these two values now. In the earlier case, I have taken minimum of these two values. So, maximum of these two values is 11.7, right. So, over here, to have the distance between 1, 2 and 3, this distance value is 11.7 in complete linkage algorithm, whereas in single linkage algorithm, the distance was the minimum value, so it was 8.1. Is that okay? So, similarly, obviously 1, 2, 1, 2, the distance is 0. Okay. So, this is 1, 2, 3. So, here also it will be 11.7, right. Now, the distance between 1, 2 and 4, I have to find out what is the distance between 1 and 4, that is 20.0, 2 and 4, this is 16.0. I have to take the maximum of these two distances, which is 20.0. Okay. So, the distance between 1, 2 and 4 is 20.0. Then distance between 1, 2 and 5, distance between 1 and 5 is 21.5, 2 and 5 is 17.9. I have to take maximum of these two distances, which is 21.5. Okay. So, in the same manner, this becomes 20.0, it becomes 21.5. Okay. 3, 3, distance is 0, 3, 4, it remains the same, because I have not, these are singleton clusters. So, distance between 3 and 4 is 9.8. Distance between 3 and 5 is also 9.8. So, distance between 3, 4, 9.8, this is also 9.8, 4, 4 is 0, distance between 4 and 5, 8.0, it is 8.0, here it is 0. Okay. So, now what I have to do is, I have to find out what is the minimum of these distances. Okay. So, what is the minimum of these distances? The minimum distance is in this case 8.0. Okay. So, when the distance is 8.0, then naturally I have to combine these two feature vectors 4 and 5. So, again, sorry, have I made any mistake? What is the distance between 1, 2 and 3? Yeah. So, here also it comes out to be the minimum distance is between 4 and 5. So, I have to combine this 4 and 5. So, I have got 1, 2 as before, then 3 and then 4, 5. Okay. So, this is the same cluster. Even up to step 2, I get the same set of clusters. So, even up to step 2, I get the same result, that 1, 2, 3 and 4, 5. And next I have to compute the same distance between 1, 2, 3 and 4, 5. Okay. And when you compute this distance, you find that the distance will be something like this: 11.7, 21.5. Okay. Then here also it will be 11.7, 21.5. Here the distance value will be 9.8. Here it is 9.8. Okay. So, following this complete linkage algorithm, I get such distance values, and the minimum of this is now 9.8. Okay. So, that means now I combine this particular cluster having these points 4, 5 with the set 3. Okay. So, over here the clusters that I have got is 1, 2 and 3, 4, 5. Okay. And then finally, these two clusters will be combined together to give you a single cluster having all the feature vectors in that cluster. Is that okay? So, here you find that there is difference between what we have got using the single linkage algorithm, because in single linkage algorithm we had 1, 2 and 3 in one cluster, then 4, 5 in another cluster. Here we have got 1 and 2 in one cluster and 3, 4, 5 in another cluster. Okay. So, up to stage 2, up to step 2 we had the same result, but in step 3 onwards our results are different. Okay. Now, what is the conceptual difference between this single linkage algorithm and the complete linkage algorithm? In case of single linkage algorithm, we have taken the minimum of the distances between pair of feature vectors, where one pair is taken from one cluster, where one feature vector is taken from one cluster and the other feature vector is taken from the other cluster. Okay. Whereas, in case of complete linkage algorithm, we have taken the maximum of the distances. So, complete linkage algorithm says that it is always guaranteed that the distance between two feature vectors with one feature vector from one cluster and the other feature vector from the other cluster is always bounded. Okay, because whatever distance value I am taking, that is the maximum distance between pair of feature vectors, one from one cluster, other from other cluster. I cannot have any other pair having distance more than that. Okay. So, the clusters that you will form using this complete linkage algorithm is more compact. Okay. Whereas, in case of single linkage algorithm, I am taking the minimum distance. So, even if I have a linear cluster, one linear cluster and another linear cluster, okay, I can have 2 points, one from one cluster, other from other cluster, which are nearest. But the maximum distance may be much more than this. Okay. So, the cluster which will be formed by the single linkage algorithm will not be that compact as the cluster which is formed by complete linkage algorithm. Okay. And in case of average linkage algorithm, what we have done in this case is that either we have taken the minimum distance to compute the distance between two clusters or the maximum value to compute the distance between two clusters. In case of average linkage algorithm, we have to take the average of all the distance values between pairs of feature vectors as the distance between two clusters. So, the average linkage algorithm will give you a compactness which is in between the one which is given by single linkage and the one that is given by complete linkage. Okay. There is another algorithm, a similar agglomerative algorithm, but that is not based on simple distance values, but it is based on the variance of the samples in a single cluster. Okay. So, it tries to form the clusters in such a way that the variance of the samples in the same cluster is minimum. Okay. And that is an algorithm which is Ward's algorithm. Okay. So, Ward's algorithm forms the clusters where the variance within the cluster is minimum. Okay. So, suppose we have a cluster C j with say m number of feature vectors. Okay. We can term them as x1, x2 up to say xm. Okay. So, obviously, the error within the cluster that can be defined as Ej, which is equal to xi minus mu and take the summation over I varying from 1 to m. Okay. Where mu is the mean of all these feature vectors. So, this is the error within the jth cluster. Okay. And you find that this is nothing but m times sigma square, where sigma square is the variance of all these feature vectors. Okay. So, using Ward's algorithm that tries to minimize this or that tries to minimize this error. Okay. And the total error of clustering E that can be defined as sum of Ej for all j, that is the within cluster error, sum of within cluster error over all the clusters, that gives you the total error of clustering, right. So, in this Ward's algorithm which tries to minimize this variance of individual clusters, obviously that also tries to minimize the total error of clustering. So, this ensures that when I form the clusters, every cluster will be quite compact, because only for a compact cluster the error within the cluster will be minimum. Okay. But at the cost of what? Obviously, at the cost of computational complexity, because at every step I have to consider every possible combination. So, when I want to combine in the first step, when I want to combine two most similar clusters, I have to see whether 1 and 2 can be combined together, 1 and 3 can be combined together, 1 and 4 can be combined together, and so on, right. So, I have to try with 1, 2 in a single cluster. So, in the first step I will have things like this, that 1, 2 will be in a single cluster, then 3 will be in a single cluster, 4 will be in a single cluster, and 5 will be in a single cluster. And because these 3 are singleton clusters, so obviously the within class error or within cluster variance for these 3 clusters are 0. Okay. So, within cluster error will be coming only due to this, and you find that if I compute following the same set of feature vectors that we have taken, this will come out to be something like 8.0. So, this is what is within class error or within class squared error. Similarly, I also have to try out 1, 3, 4, 5 and 2. This is another possible way of combining, and if I compute the within class error or the total error in this case, this comes out to be 68.5. Similarly, I also have to try out 1, 4, 2, 3 and 5. This will come out to be something like 200.0. Similarly, I have to, so all possible combinations with 1. Similarly, I have to try out all possible combinations with 2. So, 2, 3, 1, 4, 5. Similarly, I have to try out with 2, 4, 1, 3, 5. I have to try out 2, 5, 1, 3, 4. So, in this manner, I have to try combining 2 clusters into a single clusters and all possible ways in which 2 clusters can be combined together. And for each of these combinations, I have to compute what is the total error. And I have to accept that particular combination for which the total error is minimum. Okay. And this operation I have to perform n minus 1 number of times. Okay. So, though Watt's algorithm gives you the clusters which are much more compact, because it is trying to minimize the total error or total within class errors. So, obviously, in terms of error, this clustering will give you the better result, but obviously at the cost of computation, because the amount of computation that I have in this case is quite enormous. Okay. So, I will stop this agglomerative clustering with this. Next class we will try with other clustering techniques. Okay. Thank you.